This conference will now be recorded.
Tilo Soennichsen here, hello. Today I will show you FileNet, IBM FileNet system, the container version running on Kubernetes on the Azure AKS Kubernetes system. IBM FileNet supports any CNCF certified Kubernetes system since March 2019. Before that, it was tied to ICP, IBM's Cloud Private Kubernetes version. FileNet containers are actually around since late 2017. That's when we joined the early adopters program and have worked with containers ever since. The version who is supported for any CNCF certified Kubernetes version is called DBA 4MC, Digital Business Automation for Multi-Cloud version 1802. This name will change, by the way, soon to IBM Cloud Pack for automation. So you don't need to remember that name. And later this month, there's a new version coming out with some further changes. Okay, so what do we have here? Let me first show you what we have created on the infrastructure side, in this case on Azure. On Azure, we have an Kubernetes service set up. And as part of that, we selected to have 3 nodes. You can see that here right now. We have 3 nodes. I could scale that up and down. There's some automation, depends on the provider, to do this in an automated fashion based on demand, based on certain other events. It's quite flexible. After this is created, behind the scenes, in this case, Azure as a provider creates various objects. Let me show you that. So we have here, one second. As part of that creation, we have here a few artifacts created. Most importantly, you can see we got 3 VMs, which are powering our AKS cluster. And in this case, with Azure, from a payment perspective, we only need to pay for the resources used. That means in this case for the virtual machines, for the disks for the virtual machines, for other storage, and for external static IP addresses. So that's kind of the artifacts you can see here created by Azure for our Kubernetes clusters. We don't need to maintain any of this, so that's all done by the Kubernetes service. Okay, let's jump right into a little bit how Kubernetes looks like. So this is the Kubernetes GUI. Kubernetes can be accessed via GUI. This is a standard GUI. There's also an extensive command line way of accessing and configuring and modifying Kubernetes. So you have both options there. What can we see here? We can see an overview about our Kubernetes system with CPU usage, memory usage. We can see here our deployments. We can see our pods, replica sets, and other artifacts from our Kubernetes services. So the three nodes I selected to power our Kubernetes services, you can see the details here. It's called agent pool, and then if you're even interested to dig up another layer, you can see details of that. And again, that's all done by the platform provider from Kubernetes, in this case, Azure's AKS. But in case you're curious what's going on behind the scenes, you can review it here. So for example, Microsoft decided to power this with an Ubuntu operating system, wants a Linux kernel, and some other version information. You can see the allocation from this node. You can also over allocate and various other options. Okay. Before I show you the FileNet deployment, I will first show you the FileNet running. So here we have our Content Engine ping page, the status page. You can see the host name here. It's ECM CPE with a randomly created suffix. You can see right now I have it running under a DNS from a simplest way to get the dev system up here. A DNS from Microsoft Azure. You can also use your custom domain. You can actually run this also on-premise. You don't need to run it on cloud. So if you have an on-premise CNCF certified Kubernetes, you could run your IBM on-premise and fully IBM supported because it's CNCF certified. Okay, what else we got here? We got here our navigator ping page. You can see similar information. Our host name slightly different. We run both with a SQL database at the backend. Currently officially not supported. End of the month that should be there, but for our dev system, demo system here, that's working. Here you can see navigator up live in action. If I didn't time out. So here's our navigator. So, okay, how does it all look on the Kubernetes side? So we have various deployments here, deployment set as part of this. Oh. So here's our deployments. And right now I decided to have most of my ECM related items running with one replica only. So you can see only there's one pod. The CSS I already have run with two pods. So it's a replica set of 2. All others are here replica set of 1. You can see we have the CPE, ICN, we got CMIS, CSS for the search, we got the external search, and to support the external share, I also got the external LDAP here running just to feed the external share feature, and we have an ingress controller who controls the incoming traffic flow. So provides a FileNet system, in this case on this URL, and takes care about the SSL termination. Okay, so for example, if I want to right now scale out my CPE, right now I have one replica set of 1 with 1 pod running. I can do it via the GUI, I can do it via command line, I can do it in automated fashion. And in this case, I will just show you how I can scale that in the GUI. So I would like to have 2 pods. So now the system is creating a second pod of my CPE. Depends on the policy, it will pull the image or use the existing image. And based on various readiness probes, Kubernetes will then decide when it's ready to route traffic to that new pod. It depends on the ingress controller, on session stickiness. It will then route traffic to that new CPE. This can take a few minutes. While this is going on, I will show you the configuration files who feed the FileNet system and show you a little bit of the great flexibility of running FileNet containers, in this case on Kubernetes. Before we go there, I can also see the status via command line. So here you can see that we are right now having 2 CPEs. You see the suffix here. One is ready and one is right now in the creation process, so I could get details of that through the command line or also through the GUI. There you can see our new CPE instance. And grabs a container image and then starts a container and then has some readiness probes. So let's jump into the configuration. This is the deployment file of the CPE, a configuration file of the CPE deployment on Kubernetes. You can use Helm supported deployment. That's a little simpler, but a little less flexibility on the storage assignment and such, but it's available. So what do we have here? First, we define the servers. with ports and what apps belong to it. I comment out the ingress configuration because I have a separate ingress configuration file for managing the ingress of the entire FileNet system, not just CPE. We have here the deployment. Originally, I configured with a replica of only one. That's what I in the GUI just changed to 2. And there's various other configuration like, okay, where do we get the image from? Where do we get the container from? What are the minimum starting CPU and memory allocated to this one pod? And what are the limit of usage of CPU and memory? Here we see environment-specific information for that container, and a couple of important information for the CPE is what is the GCD database connection, the GNDI name, so it can connect to the GCD database. Here you can see the information how Kubernetes determine if a pod is ready or a pod is still alive. So the readiness probe goes to the P8CE health page, and the same for the liveliness probes. So that's how Kubernetes know if CPE, if this pod is alive, if it can route traffic to it, and also if a new pod is created, if it's ready to route traffic to it. So that's built in Kubernetes. You don't need to worry about that. Below here, we have our storage configuration, and lots of this storage configuration is not your traditional storage for your object store. This is for the configuration and log files. We also have storage configuration for the object store. This is this one here. You could use this one, and then your object store storage configuration just looks like your traditional right now. You could also utilize some of the newer object store storage options for directly using a cloud storage and such. So there's quite some flexibility on the storage for your object store. You could also use the traditional for FileNet looking local storage. It still, in this case, ends up on our Azure storage account. The configuration files itself, we have here in the config drop-in overrides, which we mounted from here. So I can show you them right here. That's our override folder. By the way, this is my root, how I organize the storage. You have some flexibility how you want to do it based on the subpaths we just saw in the configuration file. But here for the CPE, we can see the logs. We can see the logs for the various servers and the config overrides for the database connection, for the LDAP connection, the database driver, and also the SSL key store. So let's jump back to the config file. So for example, here's our database connection. So you can see this configuration file can easily be reused if you want to set up a second FileNet system, or you need to create a new sandbox system or such. You could reuse this and just point it to another database. So that's a great flexibility of reusing your configuration files. This one is telling the object store database to use, in this case, cube12_fnos. That's the database to use and how to connect to that. Again, officially, Microsoft SQL is not supported. That should come later this month, but it works fine here on our demo dev system. Here's the LDAP connection. In this case, we point to a Microsoft Active Directory. We use Azure AD with ADDS. There's some things to consider there, but that's what we use in our demo dev system here. And next, we got the external LDAP connection, which I just use for the demo purposes, a small open LDAP, which we connect as IBM Tivoli directory server. Okay, let's see if our other CPE is ready, and I can show you how we connect to that. So we can see the other CPE is running for 7 minutes now. status is ready. I can also check that in the GUI. So now if I go in a new browser, so this one should still point us to this due to the session stickiness. Let me see if I can open a new browser to show it to you there. Okay, here's another browser window, and you can see that it points to the new CPE. You can also see startup time here to reflect our new creation. That's all UTC time. So you see how easy it is to scale out the FileNet system, and the same applies to the navigator. If I want to have more navigator instances running, I can just increase the replica count as needed. If you at some point need to scale out your physical resources or your resources of your cluster, you would do that on the cluster management. In this case, on my AKS, I can scale it out here in case in this current scenario with the 3 VMs, if they don't provide enough power, then I could scale it up here to have more CPU power, more memory. Okay, so that is what I would like to show you for today. Please let us know if you have any questions or would like to get another insight in running FileNet containers on Kubernetes. I think it's a great, exciting technology which will simplify FileNet deployments heavily and also allow reusability of the various configuration files to create new systems. Talking about upgrades and such, right now the configuration file gives you the flexibility to control how you want to would roll out a new container. So if IBM FileNet release a new container, in this case, I point directly to a version image. That's my container image. I could also, in this configuration file, say latest prod, and then I would tag my container image and my container registry accordingly so that it would pull whatever is tagged, which version is tagged to be latest prod or latest, however I want to set that up and deal with the deployments. Okay, that's all. Thank you very much. Bye-bye.